Good afternoon. This will be a short agenda video. First of all, regarding the, it's like an ongoing topic, the replays of the videos. I mean, on the one hand, maybe it's like, I need to be, I don't know, happy. I don't know that people actually are interested in stuff. But on the other hand, I mean, I cannot replay everything all the time. So there's so much stuff, so many series, so much videos. People are always replacing, I don't have a solution for that, like the problem of like what's the correct thing to play and why people can't just, get it using, cyber stuff. I don't know, whatever. I mean, that's what you do, you're a hacker, so hack, whatever, and get it. Now with regards to science, so yesterday I was still very tired, I slept quite a bit. So I'm thinking about, the results. The important stuff is always not to start, every kind of endeavor from the first, from the first step, from Gita Aleph. To try to think like how what you do relates to what you already know and you've already done. So first, regarding the train bacteria, you cannot really, produce a train bacteria, just by so quickly, It was just like kind of like a long shot. That we didn't find train bacteria yesterday, in the container, it's obvious, because why should it be there? It wasn't there to begin with. You can create it ex nihilo, but it requires some effort, and I'll do it, maybe today, maybe tomorrow, and I'll show you how it's done. But you need a little bit more than just, 5 minutes electrolysis, like, with this simple symbol. You need a little bit more, and we'll do it. And I'll take the effort to create the huge train bacteria that is like more robust and bigger. So, and we'll make it. We will have our culture of train bacteria. I promise. Should be said that very shortly that the train bacteria does not grow and multiply just by the mere fact that you put it like on like generic microbial meal, which is more traditionally made of stuff that is called agar. It's kind of like it's all sort of it's a mixture of chemicals, and you can produce it like there are homebrews for that as well. You don't need to buy like from chemists. But mostly, what you do if you create for cultures of microbes, it's just the simple just a simple meal that is made of agar, which is like chemicals with that are a little bit of water that are made to be like a little bit like cream, or like a very kind of like soft wax. And it's known that it's like the standard meal for different microbes like different things, they have different culinary preferences, and sometimes they are on different diets. Atkins, paleo 30 days challenge, Middle Eastern stuff, יש גם את דיאטת הכרוב, אתם מכירים את זה, דיאטת לחם, יש, but generally, they mostly like agar. That's why it's so, that's what people use. It's like a cream. Like the homebrews are mostly bouillon, like, meat or chicken bouillon with a little bit of sugar and gelatin. Anyway, and then you put it and then you can just place it wherever. But what you do, in the קופות חולים, medical, hospitals and physicians, places that, I mean, they put it like in an incubator, like to warm it up a little bit. And then, I mean, you know, the microbes, they have, like, you know, relatively high temperature, not too high, and they have, like, you know, their food, and they just multiply. And after, between 4 and 7 days, you get a culture that is visible by the naked eye and can easily be detected by a microscope. And, like, you know, this can be done in any home. It's the simplest thing. And somehow, you know, when you give a stool sample to, you know, to again, like קופת חולים, like in Israel, that's what you do. I'm not even sure how to translate קופת חולים. Like, I mean, in Israel, it's like where you go when you're sick, like קופת חולים. It's like an ancient institution. I mean, I think it was invented by Napoleon or something, but it's still a very dominant institution in Israel. Some people are very proud of that, presumably, and some people still think that it's like the epitome of, like, you know, Israeli success is קופת חולים. I don't have an opinion on the matter too much. I mean, whatever. I don't have a strong opinion on the matter. Anyway, they do it in 2 days. I mean, so maybe there are ways to kind of like to quicken the process. I mean, but it requires time anyway. You cannot do it in less than 2 days. Anyway, all of this probably is not going to, not probably, certainly, most certainly, undoubtedly, will not create a culture of trained bacteria. And probably, if it would, all of you would have been dead a long time ago, which also means that trained bacteria would, I mean, it would have put it, like, you know, in a category of microbes that are super duper aggressive, unbelievably aggressive, which means that it had no way to survive, actually. Because the more microbes are aggressive, the less they are infectious. This is an only thing. It's a mathematical truth. Because they kill the host, and then they can't infect other hosts. And generally, with time, new mutations, many times they are more aggressive than their parents. Like, that's why they say, you know, in the news, there was okay, מוטציה חדשה של הקורונה שהגיעה מהנילוס, או מוטציות על דלטה שהגיעה מהירח, או לא יודע, או מוטציה של צ'אן לי שהגיעה ממעבדות סודיות בסין. יש כל מיני כאלה חדשות, הרבה יותר אגרסיביים מאי פעם. So just so you know, this is like a mathematical issue. I mean, this is mathematical issue. I mean, new mutants, mostly they are more aggressive than their parents, because otherwise they wouldn't, I mean, wouldn't have like a chance, like, you know, to compete against their predecessors. So the fact that you know about it probably means that it started like as a more aggressive variant of something that you already know. And then if they catch up, if they kind of like, you know, they become spread, like they get their, you know, 15 minutes of fame, what happens is that they become less and less aggressive with time. Again, it's a mathematical process, and the reason for that is that the less aggressive they are, the more they have like more survivability in the long term, because they can infect other people better. I mean, they have more chance to infect other hosts. I mentioned Helicobacter pylori like a couple of days ago. I'm not even sure in what was the context. Anyway, this is the most successful microbial parasite that exists in Earth, from the context of human. And it's 50%, according to approximations, 50% of the people are infected with this. And it's mostly, it's just, I mean, when they get it, they stay with it for life, unless they specifically take medicine to kill it, and most people do not take the medicine. There are no medicine to kill this thing. It resides in the stomach. or maybe a sterile, I think it's the stomach. Anyway, in part of your digesting system, where most of the microbes in the body exist actually. Like most of the good bacteria, but this is not a good bacteria, it's a parasitic bacteria. And it's the most successful parasite in Earth, because successful according to the definition that it managed to infect 50% of all humans, billions of humans. Now why people don't bother to kill it, even though it's got a medicine? Because doctors don't know like if anything bad that it's doing to humans. They don't know of any negative effect or positive effect. Like the common stand in the medical institution is that it's just there. Like, I mean, they don't understand what's doing, like, I mean, besides being there. And of course, this is not by chance that it's like that. Because it's so non-aggressive, it managed to be so infectious and to infect like half of all humans, billions of people, and people don't even bother to get it out. So this is normal evolution of microbes. The new variants are aggressive because otherwise, how can they make names to themselves? But then, I mean, they usually become less aggressive in order to be more infectious and to be able to try and to become, legendary, like the Helicobacter priori. Now, if the trend bacteria would have grown, because it can grow, unlike other microbes, it can. I'm going to show you in the next couple of days. Hopefully, trend bacteria in all sorts of sizes. We will actually grow it here, and you will see that. I mean, it's completely unnatural, from the perspective of normal, microbiology, because normally, microbes don't have like variety of sizes. Maybe, they are born, they're babies, and then they grow up, and they become adults, and that's it. But these things can go. It's like a human that can go to 10 meters, and then 100 meters, and then kilometer, something like that. And you don't need to believe me because it was documented in this channel, and hopefully I'll show you how it's done in the next couple of days. But if all it needed in order to grow and multiply would have been just simple bacterial food and worms, I mean, not warm, I mean heat, then I mean it would have been pretty quickly. I mean, it would have been spread all over your body, and and terminate the host, and then terminate, and then it would have. How can it infect other people that way? So it's not beneficial for this kind of bacteria to be so how can I say it? I mean, promiscuous. No, there is another word, scientific word for an animal that go and multiply very kind of generously. I mean, I don't know the word. It's not in just to say that even the existence of very small amount of very small train bacteria, small compared to what I'm going to show you in the next couple of days, hopefully, can devastate humans. I mean, mostly it doesn't kill them, but it creates long-term neurological effects, and it drives people crazy. And I mean, it's like a long-term nightmare. And many people in Israel are infected with that, and also Titans. So you can just ask them how it feels. And mostly they have relatively small amount of the stuff in their body, and also smaller variations. And generally, the medical establishment cannot even find it in their body, because it's so small and not numerous, and mostly, and the most important stuff is that it doesn't go in normal culture. That's the main. I mean, that's the main reason. I mean, how can you detect it if you don't know how to grow it in a culture? צריך פוקס, אבל למה שיהיה פוקס כזה, סטטיסטית? פוקס בלמצוא בדיוק שתיקח את הדגימה, ובדיוק שזה יהיה שם אחד, ושהוא יהיה ענק ותמצא אותו, הסיכוי הוא פשוט אפסי. That's why, I mean, cultures were invented for any kind of bacteria. But again, the term bacteria is like, it's not that fecund. I mean, the fecundity, I think the proper name is fecundity. Fecundity. Like, the fecundity of the term bacteria, like, I mean, is more complicated than that of, like, Salmonella or E. coli. I mean, it's not going to, it needs special, like, special triggers and special environmental factors in order to lay its eggs. It lays its eggs in clusters. Not just, all over the place, but in clusters. And it doesn't, like, it's not going to do it, like, anytime, like, it's the first opportunity that it's possible. Like, it's going to wait for the correct time to lay the eggs. By the way, this in itself kind of, like, make it, relatively, like, strange animal. Because other bacteria just, I mean, they just, I mean, multiply by, I don't know what's the biological term, but they mostly just, I mean, just split to two, like one is split to two, and then there are two, and then there are four, but it's not the way that bacteria is doing that. The way that they do it is with eggs, actually. Which makes it, I mean, so it does not conform to normal behavior of, like, the known, the usual microbes that, I mean, you find, like, in people, again, like the flu, or flu is, I think, is a virus, right? Virus is another thing. Let's leave virus aside. But I mean, germs, like, the known germs, like, whatever. What are nice, Carus vibactus. Anyway, this is something different. So what I'm going to show you, hopefully, the next couple of days, is how can we incite it to grow and multiply with the help of the neurons, using both electrolysis and crucible approach, and of course with, I mean, the correct symbology, because we need the correct symbology in order to tell the neurons to actually do what we want, which is to help the bacteria to grow and multiply. This might be, I didn't think about it like until the last couple of days, because the time bacteria wasn't like a huge topic in this channel until pretty much lately, until the last couple of months. Even though it was featured in the channel long ago, like even monsters once, and it was discussed, but one in a series of other monsters, like a specimen among monster gallery, that were all sorts of other things were discussed in the channel. I didn't know it was so important. I didn't know it's of its, like, the role that it took, like, in the 20th century with regards to the intelligence services, and although I didn't know, I didn't understand, like, the relationship between the bacteria and the phenomenon of what I call the sheep, which are, the human women, like in Israel, that, I mean, that basically they are all infected with this thing. And that's integral to the existence of Israel, because these sheep are marrying the dogs, because there aren't enough pigs to marry the dogs. Certainly since the 1970s. So it's a huge political issue. But I didn't know all of that until pretty recently. Anyway, the term bacteria is more kind of like in my mind in the last couple of months, because I became more aware of its importance to humans and titans at the current situation. And one of the things that I thought about recently is that the procedure that allows the multiplying and the growth of the trained bacteria sometimes goes to monster sizes. Actually, it's something that I've done several times in this channel since like 14 months ago, or more than that, since 16 months ago. This procedure, if we refine it and make it more rigorous, and also, and that's an important thing, if we are able to be certain, I mean, if we formulate in exact way the difference between creation ex nihilo and growth and multiplication of existing things, and I think I'm almost certainly, I think I know the difference in the symbolic language, but I admit, admittedly, I'm not 100% sure because it wasn't that important. Like this is the distinction. Philosophically, it's important, but philosophically, I already know that the neurons can create things ex nihilo. I have a tremendous amount of evidence for that. Like I don't need further evidence for the fact that vivo ex vivo is false. This was already established long ago in this channel. And from the practical perspective, until now, including now, but like the new thought that I'm just now, this is the first time that I present this issue, because it's the first time that it kind of like it occurred to me, like in the last couple of days, as part of this long series of experiments of slightly energized and everything we discussed in the last couple of days, like the series of experiments that I show you, and and again, it's not like the DC over from February that was kind of like that I knew exactly what I'm going to do, because so it was like textbook, the science, which was much easier and with predicted results. This one was intended from the beginning to include new elements. So of course it's much longer and it's less kind of like predictable, which is fine. It's mostly what I do. So as part of that, I thought for the first time about the issue of detection. But other than that, for practical perspective, including the practical perspective of what I do right now, it usually doesn't matter this distinction of create something ex nihilo and then multiply it and grow it, like a certain life form. The distinction between this command and the command of grow and multiply and grow specific life forms that already exist in the container, usually it didn't matter to me until now. Because, why should I care? The result, I want the result. And the results are the same for the two commands. The results are the same. That's why, it wasn't that important to me to be 100% clear about the distinction between these two commands. I think I know what's the difference in the symbolic language. I'm almost certain I know. And I also discussed it in the past in this channel. But I'm not 100% certain I understand the distinction. And of course, in order to be 100% certain, we need to create like a line of experiments with control groups that will make us certain that, yes, indeed, this command tells the neurons, create something ex nihilo, create like a life form ex nihilo from the inanimate matter, and then grow and multiply it. And the other command means go and multiply these life forms. And the other command will produce nothing if there is not already at least, a couple of specimens of this life form in the mixture. Now, even for our purpose, it's not that important right now, because again, what we want is we are interested in the in the result, which means we want a container full of trained bacteria, preferably with at least one or two huge specimens, like monster specimen. That's what we want, because we want we want it for the Colosseum, for the microscopic Colosseum. We want to see how the neurons are fighting it. But this distinction can actually be critical if you want to detect the trained bacteria. Or in other words, if you want to create a culture of the trained bacteria, probably from a human or Titan stool sample, but you want the culture to be created as any normal culture, which means only if there is some kind of population that already exists. I mean, that's the idea behind the culture. I mean, because either nothing will go, either after 4 days there will be no germ will be detected, or it will be full of germs that are actually visible many times by the naked eye, and certainly could be easily isolated under the microscope using all sorts of staining, even relatively primitive techniques like gram staining or things like that. And nowadays, I mean, you can use. I'm not sure like everybody uses it, but you can even identify the microbes. I mean, by like a vision algorithms, so sometimes you don't even need a laboratory worker. Sometimes I mean all that can be done totally automatically. But I'm not sure how spread it is. I think it's like a high tech medical practice that I'm not sure it's certainly not all over the world. But I mean the classical way to do it, which is done since at least 150 years all over the world, is that I mean you place the culture in you don't even need to place it you don't even need to. You actually don't need even to place it in any. It doesn't matter where you place it, as long as it's not freezing. I mean, you place it somewhere actually, and then after a few days, you just you place it under. You watch it under a microscope, and like a laboratory worker, and then and the laboratory worker can just by watching the germs and staining them with crude staining techniques. Not as good as what I do. I do the Paleolithic style staining of don't do that. I mean, but less good than what I do, but a kind of good staining technique that that are known more than 100 years. It can increase the visibility and the contrast of the germs under the microscope, and then with a little bit of experience, this laboratory worker can tell you this guy they have Salmonella or Streptococcus, something like that. But today, actually, this can be done even with computers. And of course, all of that is predicated on vivo ex vivo, or on the fact that something cannot grow if it already does not exist. It cannot multiply if it already does not exist, which is of course not true, but it's true enough for humans, for most applications. Already, although again, this procedure, which is probably one of the most, if not the most common medical procedures in Earth, is also predicated on the notion that microbes will just go. I mean, all of the things you need is the basic the basic food, the agar thing, and even other stuff and the more even less sophisticated than that probably do the job, and just simple relatively warm, but even that is not microbes usually don't require much. They don't have many demands. They are modest creatures. Mostly they don't want much. But the bacteria isn't like that. It's like a prima donna microbe. It requires all sorts of things. And again, if it wasn't like that, all of you probably would have been dead already, but it also means that the bacteria would have been dead, because how can it infect each other if all the hosts are dead? So there is a mathematical, logic behind all this stuff. So we might want, as part of this growing list, for the growing list of objectives of this kind of series, to better formulate the symbolic language, the difference in the symbolic language between between create, multiply and grow, and just multiply and grow without the create ex nihilo. And this will allow us to actually be able to detect if a sample contains the trained bacteria. The same way that it's done with cultures, but in a way that will actually work with the trained bacteria, unlike normal laboratory cultures. And this can be very interesting. Can this procedure enough, let's say that we formulated, now be incorporated, like presumably all over the world, to allow the detection of the trained bacteria in patients? First of all, I should say I'm not sure that there is not already procedure. I mean, maybe there is already a way to detect the trained bacteria. I mean, positively detect the bacteria, which is not, behavioral, because you can do it, because, using behavioral attitude, just to say, that, okay, this person is Israel, this person is Nazi, this person is prostitute, this person is part of the Shabak, this person is addicted to the tea, this person prostitutes to pee on his face, this person complains about neurological symptoms, he has the trained bacteria. That's one way to detect it, to do רפואה מבחנת, as they say, I don't know the English term, like to do what House is doing, the diagnosis medicine. It's a way, it's a proper way. But I'm not sure, maybe there is also an empirical, biological way. I'm not sure. If there is one, please, enlighten me. But let's say, I suggest now such a way that is based on procedures like what you're going to see in the next couple of days, and hopefully, if God allows, Bezrat Hashem, and also, of course, in just a little better, understanding of the symbolic language, or just, a small refinement of that is still needed with proof of the symbolic language. Let's say that, this now, produces like a procedure that can, positively say if a given mixture, like stool sample or blood sample or pee sample, contains the trained bacteria. Can it now, and let's say that, you don't have other biological methods to do, empirical biological methods to do so, or you don't trust this method, which I don't know if it's true or not, enlighten me. But let's say, you don't, and you want this kind of procedure, like what I suggest, as to be incorporated in whatever you do. Could you, just now use it? The answer is that I don't know. Probably not, maybe. Why? Because an integral component of this procedure are the neurons, the T. Without the T, this won't work. Now, usually, any sample, any biological sample from a titan or human body that contains the trained bacteria is going to contain some T. It's almost impossible that it's not like that, because of how did the person get the trained bacteria? The way to get the trained bacteria in our world, it's an alien bacteria. It's spread, usually because of kind of interaction, sexual interaction, or fluid transfer with people that have both T and trained bacteria in their body. Because, one doesn't come without the other. How could you be infected with trained bacteria without also getting the T in the way? It's almost impossible to my understanding. And that's the vector of the transfer. That people want the T, so they do sexual stuff in the broad sense, not necessarily vaginal intercourse, probably usually no intercourse at all. Usually just bodily fluids or bodily non-fluids or half fluids or bodily fluids and bodily non-fluids. Bodily something that is being transferred, and this that is known to contain the T, and this is also where the term bacteria will be found. And although the term bacteria itself contains the T in its body. But that's not the T that we are interested in, because it will serve the term bacteria. We are interested in the T that is out of the term bacteria. But I cannot trust that these neurons will do the job, because it's the red neurons. It's the neurons of the Titan female. And they are much less numerous and tremendously smaller and tremendously less powerful than my own, than the yellow neurons. It's a huge difference between the red neurons and the yellow neurons. And whatever I do in this channel, almost everything is based on the yellow neurons, my own neurons that were multiplied and grown and taken from my body. And if a procedure, is successful based on the fact that the mixture contains huge amount, and also I use enriched mixture, as you see right now. I don't usually use just vanilla mixture, which means just my sperm, my semen. Even though in the past it was used quite a bit. Like the first couple of months, that's how I've done all experiments were just like that. I placed something on a slide and ejaculated, and just took עם פיפט לקחתי איזה טיפה ושמתי על הג'וק ושמתי את זה בפריזר או משהו, או לא בפריזר, או מתחת למנורה, או כל מיני וריאציות. That's the way it went in the first couple of months, but it required me to be very, and I've done a tremendous amount of such experiments, but it required me, to be very fecund. I'm sometimes, like after some time, do it like 3-4 times a day. It's kind of like a hassle. It's not the worst job in the world, but mostly it's like I prefer to do it just when I really feel like I kind of like need to do it, like just not as a job. But so luckily, with the help of God, we managed to create what I call enriched mixtures, which, as you see in under microscope, mixture that were grown in laboratory. And that's and since then I use these things for any kind of experiment. So the fact that the procedure is successful or viable, scientifically viable, when it depends, like is one of the major components on some kind of amount of the enriched mixture, which means laboratory grown, sometimes to astronomical number of specimens of the yellow nero, which to begin with is much larger than the red neros and much more common in any bodily fluids that is taken from me against what it's common from a Titan female. It doesn't mean that the same thing will work with just the T that can be found next to a trained bacteria in a random sample that was taken from someone's body. Because the workers, the robots, in our case, in the laboratory case that we will try to refine and formulate, will be probably maybe 1 trillion times more numerous and more powerful than the robots that you could typically find in just a random sample from a Titan or a human body that contains both T and maybe trained bacteria. So will this procedure be of any help if we manage to refine it? So maybe it's kind of like a procedure that will be of no help to nobody, because it requires a component that is nowhere to be found. So again, I will say, it is not true that this component is nowhere to be found. What is true that in order to get this component, you need to move arms and legs. It's kind of a component that cannot be obtained using the mouse and the tongue. I mean, this belongs to a group of things in our world that requires movement of arms and legs. Because if you move arms and legs, get me, my daughters, and their mother outside of the Nazi prison, and if you do it quickly, swiftly, without a movement of the tongue while you are doing it, then with all probability it's going to be relatively easy to get this component, because I can manufacture it in any amount if I just live outside the Nazi prison and have money, and then you can buy it for me. And why should I sell it, to that I'm not a greedy person. Like, I'm not going to sell it like in unreasonable price. You know that I'm not a greedy person. If I were, my whole approach to how to deal with Israel would have been completely different. So you already know that I'm not a greedy person. So I would say this procedure might be of help anyway, but in order that, if we manage to formulate in the next couple of days, then we'll try to do it. If not, in the next couple of days, maybe it will be left like as an objective for further study down the line. So I would say this procedure, if we are able to formulate it, can be of help. First of all, if you don't have an alternative procedure, maybe you do. I don't know that it is of the same objectives and with the same kind of validity. But if you don't, and you require that kind of procedure, it can be of benefit when I'm outside the Nazi prison, after all humans are annihilated, or maybe if there is a miracle and a group of humans in Earth would make like a last-minute decision to abandon the way of the tongue, maybe.